Hello everyone, welcome to my channel. So today we are going to see how we can implement a queue using a linked list in Java. And so first, what is a linked list? A linked list is a collection of nodes which have been linked to each other using the addresses. So what does that mean? This here is a node, and in each node it contains a data part and an address, and that address part is contained in the address of the next node. So in here you can see this 120 is the address of the next node, and 1 is the data part, and this head contains the address of the first node. Regarding this linked list, the information we have to access is the head pointer. So to implement a queue using this, we have to satisfy two conditions. One is the FIFO rule, as in first in first out, then the time complexity rule, that is order of 1. To implement the queue, let's look how we can satisfy the first condition, that is FIFO rule. Here you can see I have considered the front as left, rear as right. Front node has the head pointer pointing towards it, and to implement the FIFO rule, we just have to do is enqueue from the rear, insertion from the rear as, and the dequeue or deletion from the front. That is, we can do enqueue or insertion from rear, dequeue or deletion from front. That can be easily satisfied by taking one side as front, other side as rear. That is, we can satisfy. Now the second rule, time complexity rule, order of 1. So what does that mean? It means that both enqueue and dequeue should be done at an order of 1 time complexity. To achieve this, first let's look at the dequeue part. As you can see, in dequeue there is the pointer pointing towards the first node, so that can be accessed easily using this head pointer. So that does not depend on how many elements present in this linked list. It can be easily accessed using this head pointer. Then by using the address part in this pointer, in this node, we can access the next node. Then we can update it as the first node in this linked list. That's fine. But when we want to do the enqueue, we have to access the rear. So how can we access the rear? To do that, we have to first the thing is, the information we have in this linked list only is the head pointer, that is the one pointing towards the front of this linked list. We don't have any pointer pointing towards the rear. So in that case, we have to first take temp to store the addresses. First I am going to store the first node address, then it's going to store the second node address, then it have to traverse through all of these linked list nodes to go to the rear node and access it. Now, so this is going to take order of n time complexity. That means it depends on the amount of elements present in this linked list. This does not satisfy order of 1 time complexity. So how can we overcome this? Simple. Just as we have a pointer pointing towards the front node, we are going to maintain another pointer pointing towards this rear. That contains the address of the rear node. So that's how we can overcome the this second rule, satisfying this second rule. So here, as you can see, the rear node's address is 140. So we are going to maintain a pointer pointing towards this rear node. Then after that, if we want to add another node that contains a data path, that means, let's say this is 4 and this address part is null because it doesn't point towards any other node. Then what are we going to do is, there is the rear pointer that has the address. Then by using that, we can link this new node to this rear node directly, and the address part is gonna get the node address of this new node. Then the new rear is going to be this. That's what simply how we can implement a queue using this linked list. So that way we have satisfied FIFO rule by doing the enqueuing from the rear, dequeuing from the front, and order of 1 time complexity by maintaining 2 pointers, one pointing towards front and one pointing towards rear. Alright everyone, that's it for the explanation. Now we will see how we can implement this queue in Java. First, I will give you guys an explanation on how I implemented this code. Then we can see how this code will function. Alright, so first of all, what I have created is a class called node that contains both data part and an address part. As I mentioned earlier, this gonna act as this node. This is the data part, which is an integer type. Then the next, which is node type. Then we are going to create a constructor to initialize this node by setting the data part as the new data and setting the next pointer null, as in this doesn't belong to queue yet and it doesn't point towards any other node. Then after that, we are going to move to the queue implementation. As in we have to create these nodes in order of the queue. So to do that, first I have created two attributes, that is front and rear of node type, to satisfy the two rules in the queue by maintaining two pointers for front and rear. This is gonna point towards front of queue and the other one towards rear of this queue. After that, we are going to create a constructor to initialize this queue by setting both front and rear pointers to null, because at the initialization this doesn't have any elements. Then after that, we are creating the key function, that is checking whether there are any elements present in this node or not. How we are implementing that is, we are checking whether this front pointer pointing towards any node. If this front pointer not pointing towards any node, that means it is null. Then we can simply say this queue is empty. Now for the enqueuing part, enqueuing is going to be done from the rear of this queue. First we are going to take new data as an argument to this function. Then we are going to create a node using this new data. Then after that, before enqueuing, we have to check whether there are any elements present in this queue or not. If this queue is empty, then this is the first node coming into this queue. We can simply point both front and rear pointers towards this new node. Then we can simply return from this function. Otherwise, then if there are any elements present in this, first we have to update the current existing nodes next pointer towards this new node's address. That's what I have done through here. This rear.next is the let's say this is the rear, and this rear.next is the address part of the last node. First we are going to update it towards the address of this new node. Let's say this is 160. We are going to update it from null to 160. That's what I have done here. Then after that, we are going to make the new tail of this queue the new node. That's what I have done by assigning this new node as the now new tail of this queue. This is going to be the new rear. After that, we are going to move towards the dequeue function. But also in dequeue function, we have to check whether there are any elements present in this queue or not. If there are no elements, we simply just return from this function. Otherwise, we have to take the front pointer to a node temp, and we have to assign the next node of this queue as the new front of this queue. That's what I have done through front equals front.next. This is going to be the new front of this queue. Then after that, I'm printing a statement saying this front node's data part has been removed from this queue. That I have accessed through temp.data. Data part contains the integer, that is the data part of this node. After that, let's say this was the only node present in this queue, and after that there are no other elements in this queue. We have to check that also. That's mean if after this front becomes null, we have to set the rear to also null. That's what I have done through here. If front equals null, rear should also be null. Then after that, we are going to clear the memory by setting the temp to null as well. Then the print queue function, print in the elements in this queue. First, checking whether this queue is empty. If this queue is empty, I'm simply printing out this statement, queue is empty. If there are any elements present in this, first we are getting the front pointer's address to the node temp. After that, until this temp address part becomes null, we are going to print the data parts present in this nodes. That's what I have done through system.out.print temp.data. Temp.data part contains the data part of this node. After that, data part is printed, we are going to set the new temp as the next node's address. After all that's done, I'm printing out a new line. Then all these functions will be running on the main function. First we are going to create a new queue. After that, that's queue name is list queue. Then I'm gonna enqueue 10, 20, 30. Then after that, when we are printing this, we should know they should come in order 10, 20, 30. Alright, now we will see how this code will function. Here you can see I have implemented this Java code in NetBeans IDE. Then I'm going to go to the main function to see how the code we have implemented function. First we are going to create a queue. After that, I'm going to enqueue some elements to this. First 10, then 20, then 30. Then as for the rules of this queue, the first element that should be present in this queue is 10, then 20, then 30. Then after printing this queue, we should get them in that order. Let's run this and see. See, they are getting in that order. First 10, then 20, then 30. Now let's see the dequeue function. So as in the dequeue function, you know, the first element that should be removed is the first one to come to this queue, that is 10. Let's see if that works the way we wanted to. Let's queue dequeue. Then let's run this. See, we can see 10 is removed from the queue. Now after this we will see the new queue. After printing this queue, the only element that should be present in this queue is 20 and 30. First is 20, the last is 30. See, it's in that order. Now after this, let's empty this queue by running the dequeue function 2 more times. Now when we run this, we get the message 20 is removed from the queue, 30 is removed from the queue. Then after printing this queue, we know there are no elements, then we should get the message queue is empty. We are getting the message queue is empty. Alright everyone, that's it for this video. Thanks for watching. I hope this video helped you understand how queues work using linked list in Java. If you find it helpful, don't forget to subscribe. Drop a comment if you have any questions or suggestions for future topics, and I will see you in the next one.